This video is on solving equations that have two radicals. So in the previous video you saw how to solve if you had one radical. In this case we're going to solve where we have two radicals, and in this example here we have the square root of x plus 2 plus the square root of 3x plus 7 equals 1. And I'm going to write out the steps as we do it. So your first step here, if you have an equation with two radicals, is to isolate one of the radicals. So isolate one of the radicals on one side of the equation. And so, if I just rewrite the problem here just so we see it again, the square root of x plus 2 plus the square root of 3x plus 7 equals 1. I'll isolate the square root of the x plus 2 on the left side, so that means I'm going to move the square root of 3x plus 7 to the other side. Since this is a positive, to move to the other side we subtract it. So we're going to subtract the square root of 3x plus 7 from each side. When we do that on the left side, they cancel, which is why we did it, because we wanted to isolate the square root of x plus 2. It's equal to, now 1 minus the square root of 3x plus 7, they're not like terms. You just write them next to each other, keeping the sign with the term. So one was a positive, so a positive 1 minus, and then the square root of 3x plus 7. And then what you want to do is now we want to get rid of that square root on the left side, so we're going to square both sides, right? To get rid of the square root, we're going to raise it to the second power. But if I do it to this side, I also have to do it to this side. So, all right, so to remove, I'll say the square root on the left side, or the isolated side, however you want to talk about it, square both sides, right, of this equation. So we end up with, we've got the square root of x plus 2 equals 1 minus the square root of 3x plus 7, and I'll just write it there like that. Now when I say square both sides, right, we're squaring the left side. Squaring the right side means you're squaring this entire thing, the 1 minus square root of 3x plus 7. It's not square each term, it's square the entire side. You can't square each term because it doesn't keep it balanced, right? They're not equivalent. So you're squaring each side, that's what's keeping it balanced. On this left side, the square root of x plus 2 squared just leaves us with x plus 2. That's why we did it, because you wanted to remove the radical. So you squared it because the index of the square root is 2. It's equal to on this side. Now when I say 1 minus the square root of 3x plus 7, the quantity squared, what it really means is write it twice. All right, 1 minus square root of 3x plus 7 times 1 minus square root 3x plus 7. And what we're going to do here is we're going to FOIL this. When I say that, it's different than, you can't square each term up here. So you have to write this twice and then FOIL it. Now, some people might be able to FOIL it in their heads. We'll do this just so you can see what happens. So we have 1 times 1 here, which gives us 1. From the outer, we have 1 times the negative square root of 3x plus 7, so it'll be negative square root 3x plus 7. From the inner, we got negative square root 3x plus 7 times 1, which is just negative square root of 3x plus 7. And then from the last, the negative times the negative makes us a positive. This will always be positive here. And then, because you'll have the same signs multiplied by each other, so it's going to be positive. Square root of 3x plus 7 times the square root of 3x plus 7 is just 3x plus 7. Now technically I should put parentheses around this. This is really what the inside was, but because it's a positive 1 and it's always going to be a plus that's going to get distributed through, you could drop the parentheses here. I'll put them here so you see them though, just in case. So simplifying this now, we have x plus 2. It's equal to, here I've got 1 plus the 3x plus 7. Now if I drop those parentheses, that's just plus 3x plus 7. So 1 plus 7 will give me an 8. And so we have 3x plus 8. And then minus the square root of 3x plus 7 minus another square root of 3x plus 7 is minus 2. Don't cancel these. There's two of them, right? This is a 1 is a coefficient here, 1 is a coefficient here, so it's minus 2 square root of 3x plus 7. Now remember, I dropped these parentheses only because it was a positive 1 getting multiplied through here, right? This really ends up being plus 3x plus 7 here. And that's how I combine the like terms. The 1 plus the 7 gave us the 8 there. So now, once you're here, you're going to do what you do if you have one radical in the equation, because that's what really we're doing, right? The reason we did this is to create an equation that only had one radical. When we had only one radical, what did we do? Well, you want to isolate the radical on one side and everything else the other side. So I'm going to isolate the radical here. So isolating the radical here, really what I'm going to do is I'm going to move these terms. I'm going to subtract 3x from each side. I'm also going to subtract 8. I'll do this in the same step. I think you guys can handle this at this point. X minus 3x gives us negative 2x. 2 minus 8 gives us negative 6. And then this is equal to, remember we did this so these would cancel on this side, and it's equal to negative 2 times the square root of 3x plus 7. And now remember, the goal is to isolate the radical. To isolate the radical in this case, what you really want to look at is, this coefficient of negative 2. To isolate it, you would divide by a negative 2. Now, if these terms on this side aren't divisible by negative 2, you might want to keep it there and then use it in the next step when we square. It's really personal preference, but it might make it easier. But in this case, we can divide by negative 2 to each side. When I say to each side, you really can do it to each term. Make sure you're doing it to each term, though. Don't just do it to each side and then cancel one of them. You're dividing each term by negative 2. Negative 2x divided by negative 2 makes us a positive x. A negative 6 divided by negative 2 makes us a positive 3. It's equal to a negative 2 cancels the negative 2, and we're left with the square root of 3x plus 7. And then if you remember from our previous examples, once you've isolated the square root on one side here, now we're going to raise each side to the power. In this case, the power is the second power because we have a square root, so the index is 2, so the power we want to raise it to is the second power. If you do it to one side, you have to raise the other side. Remember, our goal is to get rid of the radical, so that's why we're doing this. So once I'm here, I have x plus 3, the quantity squared, which you should FOIL, right? It's not x squared plus 3 squared. You can't bring that 2 inside of this. It's x plus 3 times x plus 3. I think you know how to FOIL that by now. X plus 3 times x plus 3, if you wanted to do it on the side here just so you could see it. Right, x times x is going to give us x squared. X times a positive 3 will be positive 3x, and then another positive 3x is a positive 6x for the middle terms, right, the outer and inner combined. And the last, a positive 3 times a positive 3 is a positive 9. So what happens when you square the x plus 3? I didn't show it, but you should be able to FOIL that in your head. Here, the square root getting squared just gives me whatever's on the inside, so we have 3x plus 7. And then now you have a quadratic equation here. You've got the highest power is 2. So you want to get one side equal to 0, and then you're going to solve by factoring if possible. So I'm going to get one side equal to 0 by subtracting 3x from each side and subtracting 7 from each side to get the right side equal to 0. And that'll leave me with, I've got x squared. 6x minus 3x is a positive 3x. Positive 9 minus 7 is a positive 2. This equals 0. And then now, once you're here, you want to solve this by factoring. To factor this, we'll, notice we have 3 terms. You don't see a value in front of the x squared. There was no GCF. 2 sets of parentheses right away here. X in front of each multiplies the 2 and adds to 3. Well, it's a positive 2 and a positive 1. So we got x plus 2 times x plus 1. And then remember, you're setting each factor equal to 0. And then solving this, we'll subtract 2 from each side. I get x equals negative 2. Here, subtracting 1 from each side, I get x equals negative 1. And remember what you have to do here. All right, because of the nature of what happens when you square these, you're forcing some of these terms to become positive. You have to check these answers. You can't just stop here. You should be checking every time you're solving an equation that has square roots in it. You should be checking your answers. When I go to check my answers, make sure you check way back here in the original. So we'll check these on the next page. So we're going to check x equals negative 2 and x equals negative 1, and we're going to check them in the original equation. So I'm going to write the equation here just so we have it. It was the square root of x plus 2 plus the square root of 3x plus 7 equals 1. And let's do a check on each of our solutions. The first solution we had was x equals negative 2. Remember, you're checking these individually. So I'm subbing negative 2 in for x. So I would have the square root of negative 2 plus 2 plus the square root of 3 times negative 2 plus 7. You want to know, does that equal 1? I'll put a question mark above that saying, we're not sure. The square root of negative 2 plus 2, that's the square root of 0. Plus here, the square root of 3 times negative 2, that'd be a negative 6 plus 7, which makes us the square root of a positive 1. We want to know, does that equal 1? Well, square root of 0 is 0. So we have 0 plus square root of 1 is 1. Does that equal 1? Yeah, 1 equals 1. It checks out. So negative 2 is a solution. So that's a good answer. We're also going to check x equals negative 1, the other solution that we had. Again, substituting in for all the x's with negative 1. So it's the square root of negative 1 plus 2 plus the square root of 3 times negative 1 plus 7. Does that equal 1? Now remember, you're substituting each variable in individually. You don't put the negative 2 and the negative 1 in the problem at the same time, right? So that's why I did this one first, and I did this one separate. The square root of negative 1 plus 2, well, that's just the square root of 1. Plus here, 3 times negative 1, that's going to be 3 plus 7, or negative 3 plus 7, which makes it the square root of 4. We want to know, does that equal 1? Well, square root of 1 is 1, plus square root of 4, well, that's 2. Does that equal 1? 1 plus 2, well, that's 3. 3 doesn't equal 1, so you're going to have to reject x equals negative 1. So, going back here, we found two answers, but negative 1 should be rejected. Don't erase it. I need to see the work for it. You should write reject next to it. Reject x equals negative 1, like I did before. So our solution then is just negative 2. So our solution for this is just going to be, I'll put it in curly braces for the set notation. In set notation, it would just be negative 2. There's only one value that makes it true. Now remember, if you went through and checked this and neither solution worked, then you would just say there's no solution, right? If you have to reject both answers, if you have to reject all your answers that you come up with, then there's no solution. There could be more than one answer. If these both work, then the solutions would be negative 2 and negative 1. But in this case, we only have one solution, which is negative 2. So hopefully this helped understand when you have two radicals. The key is isolate one of the radicals on one side first, and then you want to square both sides, right? So make sure you square both sides completely, which means you're going to FOIL the right side. This would give you one equation with one radical in it, and then you solve like you normally would, isolating the radical on one side again. The important thing that I want to make sure you understand is that sometimes people make a mistake in this first step where they try to square each term individually. That isn't equivalent. You can't square term by term, so you can't cancel the radicals in the first step. You always have to isolate one of them first. So hopefully this helps.